Yes, sir.
Okay. So now today we consider waist shape film, right? So similar in previous case, if we consider a thin film, then we have observed the path difference is twice mu t cos r, right? Here is also we will get twice mu t cos r plus phi. What is phi? Phi is the angle of wedge, right? This is the wedge shape film. So its thickness is continuously increasing and in a linear fashion. And this angle is alpha. So the angle of the wedge of this flame is alpha, right? Now, like previous, we consider an incident beam. Then at this surface, there is a reflected beam and one transmitted beam. And from this surface, it is reflected and some part is also transmitted. So we are considering the reflected beam. Right now, if we unite these two reflected beam, then we can observe the interference pattern. Similarly, from this is a transmitted beam, and after reflection, here another reflection will take place. Then from this region, we will get reflected ray as well as transmitted ray. So in this side, if we unite these two transmitted ray, then we can also observe the interference pattern. But we consider only the reflected beam, right, in case of waist shape flame. Now, you see up to the point B, it is common for both the reflected ray. Then the first ray is originated from point B by reflection backed by a denser medium of refractive index mu. And this is transmitted again reflection backed by rarer medium and then transmitted. Right, so the path difference, if we draw one normal from point D to on this light beam, then we will consider it touch at point K. So K2, the point of interference, and D2 point of interference is the same path, right? And the path difference is BC plus CD within this material, that's mean multiplied by mu, that is mu into BC plus CD minus BK. This is the path difference, right? So path difference is mu into BC plus CD minus BK. Point is clear? So the optical path difference, that is mu into BC plus CD minus BK. This is the optical path difference. Now BC, that we can write BJ plus JC. BJ plus JC. Here we have written mu into BJ plus JC plus CD. Right? Now, first we consider the angle of incidence I, then angle of refraction is R, and these two plane, this is one plane, this is another plane. It makes the waist shape plane, and the angle between these two plane is alpha. So if we consider the normal on these two plane meet at this point G, so it will make the same angle alpha. You know these things from your mathematical theory, you know the angle between two plane is same as the angle between the normal of the two plane, right? So these are the normal, this dotted blue line, and these two normal meet at point G, which makes an angle alpha, right? Now you consider this angle is R, this angle is alpha. So if we consider that CBG is a triangle and this angle is the outer angle, right? External angle, exterior angle. So this angle is R plus alpha. Point is clear? This angle. And now another thing, you consider these two are perpendicular on this plane. These two are perpendicular, and this will intersect. That is CH. So if this angle is R plus phi, this is extended. This ray is extended up to G, and this perpendicular is extended, right? Then it will meet. So this is R plus phi. So it will be again R plus, R plus alpha. So it will be R plus alpha. Point is clear? Now another thing,
Yes, sir.
yes. What happened?
No, sir. No, sir.
Okay. Okay.
Clear, sir.
Okay. Now, similarly, from the geometry, this concept, this angle is I and this angle will be R, right? This angle is also R. And one more thing we have to consider. Here you see, this is R plus alpha. So this angle is also R plus alpha. This angle, I have not written here. This angle is R plus alpha. And you see, these two are perpendicular and they intersect by this. So this angle R plus alpha. So this angle is also R plus alpha. Right? So that's mean for this triangle CHD, these two angle is R plus alpha. So this side CH is equal to CD. CH is equal to CD. Point is clear? That is CD equal to, we can write CH. One more thing you see here, mu, refractive index, that is sin I by sin R. And if we write sin I by sin R, then for this triangle, that is BK divided by BD, and for this triangle BJD, that is BJ divided by BD. So it will be cancel out BD and we will get BK by BJ. So BK will be mu times BJ. So you see here BK, that we can write mu times BJ. And here this BJ, mu times BJ, will be cancel out. So the path difference is mu times JC plus CD. Mu times JC plus CD. And CD, that is equal to CH, that I have already mentioned. CD equal to CH. So we will write here CD, that is equal to CH. So JC plus CH is a same straight line, right? So we can write mu times JH, mu times JH, this. And if we consider this straight line, that is JH, then if we consider the triangle JDH, and then we will get this angle is R plus alpha. Then this we can write, that is cos R plus alpha, that is JH by DH. That is JH by DH. This, right? So JH equal to DH cos R plus alpha. Now here JH. So mu times DH, mu times JH, that is equal to mu times DH cos R plus alpha. Now this DH is equal to twice DI. DH equal to twice DI because this two angle is similar, right? So this is 90 degree, this is 90 degree, this angle is similar, this is the common, this equal to this. So that's mean these two are congruent. So this equal to this. So that we have right. Now we consider the thickness of the slab at point this I, that is T. If the thickness di equal to T, then we can write twice mu T cos R plus alpha. Twice mu T cos R plus alpha. So the path difference between these two interfering beam is twice mu T cos R plus alpha. So if you consider with previous case, that is twice mu T cos R. Here we get only the difference is twice mu T cos R plus alpha, where alpha is the angle of wave. Now this BE undergoes a phase shift of pi, right? BE, this beam will undergo a phase shift of pi because it is backed by the denser medium. So again, if we write the condition for bright fringe, then twice n plus 1 lambda by 2, twice mu t cos r plus alpha, that is equal to twice n plus 1 lambda by 2, and condition of minima, that is twice mu t cos r plus alpha equal to n lambda, right? This is the condition of maxima and minima. This can be make it plus sign. This can be considered as plus sign. It needs to be correction. Okay. So the condition of maxima and minima that we can explain. The condition of maxima is twice mu t cos r plus alpha equal to twice n plus 1 lambda by 2, and condition of minima is twice mu t cos r plus alpha equal to n lambda, where n equal to 0, 1, 2, 3, like this. Now, if we calculate the condition of maxima and minima, then what is the width or fringe width? What is the fringe width? That is the width of a maxima and a minima. That fringe width we need to calculate. So to calculate the fringe width, we consider this picture. This is the angle of wedge alpha. Now we consider two consecutive minima. We consider two consecutive minima. One consecutive minima is located at thickness Tn, having a distance xn from its center of this wedge-shaped flame, and another, the next consecutive minima, that is n plus 1th order minima, which is located at a distance of xn plus 1, having thickness Tn plus 1. Then for this angle, we can write twice mu Tn cos r plus alpha equal to n lambda, or Tn that we can replace by xn tan alpha, because tan alpha equal to Tn by xn, right? So Tn equal to xn tan alpha, that we have written here, xn tan alpha, n lambda. And next minima, that is twice mu Tn plus 1 cos r plus alpha equal to n plus 1 lambda, that is xn plus 1 tan alpha, that is n plus 1 lambda. Now we take the difference between these two equations. Then we will get twice mu xn plus 1 minus xn tan alpha cos r plus alpha equal to lambda. Then according to the definition of fringe width, that is xn plus 1 minus xn, that is equal to lambda divided by twice mu tan alpha cos r plus alpha, right? Cos r plus alpha. Now you consider for normal incidence. If we consider for normal incidence, that is I equal to r equal to 0. So cos r plus alpha, that is equal to cos alpha. Then what will happen? This is tan alpha cos alpha. So we will get sin alpha. That is lambda divided by twice mu sin alpha. Lambda divided by twice mu sin alpha. Now, if alpha is very small, then we will get lambda divided by twice mu alpha, because sin alpha equal to alpha. So the fringe width beta in case of wedge-shaped flame is lambda divided by twice mu alpha, right? Lambda divided by twice mu alpha. That is the fringe width. This point is clear? Is it okay?
Yes, sir.
Yes, sir.
Okay, now we consider the application. That application is Newton's ring. So Newton's ring, how it will looks like, all of you know, all of you have already done this experiment. Now we will discuss the theoretical viewpoint. So in Newton's ring, the same things, apparatus is like this, that this is a light source, and the source is present in front of a convex lens. Then the light from this lens, it is parallel beam. This parallel beams falls on a glass plate, which makes an angle 40 degree with its incidence, right? This angle is 45 degree, right? Then what will happen? It will redirect in this direction. What is present here? This is a glass plate and this is a plano-convex lens. Now this plano-convex lens and glass plate will produce a wedge-shaped film. It will produce an wedge-shaped film. Here you see, in between glass plate and curved surface of the lens, it produces the wedge-shaped film. This air medium form the wedge-shaped film, right? And then after reflection from the curved surface, it will move to the microscope and one part is transmitted, and the transmitted part by reflection from the glass plate, it again enters into the microscope, and these two beams produce the interference pattern. This can be clear here. Now you see this is the incident beam. One is reflected beam, that is beam 2 by the curved surface of the lens, and another is reflected by the glass plate, right? This is one. These two unite and we can observe this type of ring pattern, right? Point is clear?
Yes, sir.
Now you see the reflection of this beam number 2, which is backed by the curved surface. Reflection by curved surface backed by this air medium. We consider in between glass plate and lens, this is air medium. So this is rarer medium. So this reflection will take place backed by rarer medium. So it does not undergoes any phase shift. But the beam 1, which is reflected back by a denser medium glass plate, right? So it undergoes a phase shift of pi, which is equivalent to path difference is lambda by 2, that you know, right? So when we consider the path difference between these two beams, in case of wedge-shaped film, you know the path difference is twice mu t cos r. Now, if we consider that is r for normal incidence, this is for normal incidence, then that can be r equal to 0, that cos r equal to 1. So path difference is twice mu t. But one of the beam undergoes a phase shift of pi. So that means twice mu t equal to n lambda. This is the condition of minima. Twice mu t equal to n lambda. This is the condition of minima. And twice mu t here, that is r plus alpha. So this quantity here, you see r equal to 0. And for small angle of wedge is very small, that is alpha nearly equal to 0. So this quantity gives you 1, right? So twice mu t plus minus lambda by 2, this is the total path difference. Now we consider for dark pattern, dark ring, that is twice mu. Here mth order dark ring is located at a thickness of Tm. So twice mu Tm, that is equal to m lambda. Point is clear? And for bright fringe, that is twice mu Tm, that is twice m plus 1 lambda by 2. This is the condition of maximum. Right? Now we consider the condition of minimum. Then we can determine the diameter of the ring. How we will determine? To do this, we consider here. Suppose the radius of curvature of this plano-convex lens is capital R. This is your capital R, right? This is capital R. And we consider T or Tm is the thickness of a particular ring pattern having radius R, right? Which is located at this point, at point P. So here you see Rm is the radius and Tm is the thickness here, right? So if we consider a right angle triangle here, you see this is a right angle triangle. Radius, this side is Rm, this is R, and this quantity, that is R minus T or Tm, right? So from this right angle triangle, we can write R square equal to Rm square plus R minus T square. This is R square equal to R minus T square plus Rm square. So Rm square that is equal to twice RT minus T square. Now, if T is very small, because angle of wedge is very small, so T square is also extremely small compared to capital R. So we can neglect this T square, that is Rm square equal to twice RT. Now this twice RT, T, you can put it from here, that is m lambda divided by twice mu. M lambda divided by twice mu, where T equal to Tm. So here Rm square, that is m lambda divided by twice mu. So these two will be cancelled out, right? That is Rm lambda divided by mu, Rm square. Now this is the condition of dark fringe, and for bright fringe, that is Rm square twice R into twice m plus 1 lambda by 2. This is 2 divided by mu. Now if we calculate the diameter, then Rm equal to dm by 2. So it will be multiplied by 4. That is dm square, that is equal to 4m lambda divided by mu. And here it will be dm square equal to multiplied by 4. That 4 2 will be cancelled out. That is 2 into twice m minus 1 or plus 1. We can say plus 1 lambda r divided by mu for bright fringe. Right. So this is the diameter for dark and bright fringe. A method. Now you consider the difference between two consecutive diameter. That is dm plus 1 minus dm. That is equal to 4 lambda r m plus 1 minus root m plus 1 minus root m. Right? Because for dark pattern, this is the dm square. So dm equal to 4 lambda r. If we consider mu equal to 1 for air medium, right? Mu equal to 1 for air, then root m plus 1 minus root m. Now if we put m equal to 1, 2, 3, 4 like this, then the separation between the diameter, that is d2 minus d1, which is equal to 0.414 multiplied by this quantity 4 lambda. d3 minus d2, that is root 3 minus root 2, which is equal to 0.318 root of 4 lambda. Then d4 minus d3, that is equal to 0.268 root of 4 lambda, and so on. So now you see this quantity is constant, but this value is continuously decreasing. That means the separation between two fringes are continuously decreasing, right? Separation between the fringes is continuously decreasing. So this indicates the fringe pattern are become closer and closer if we move away from the central fringe. If we move away from the central fringe, the fringe pattern are more and more closer. From this picture, you can observe. This is the separation between these two fringe. This is the separation, but if you move here, you see the separation is decreasing continuously, right? That can be proved here. Point is clear?
Yes, sir.
Now,
Yes, sir.
another thing, we need to determine the fringe width. So fringe width, that is the separation between dm plus 1 minus dm, that is the fringe width, or we can consider that is r radius. In terms of radius, it will be better to say, but we can say also in terms of diameter. So this difference is this quantity 4 lambda divided by twice dm. Why? Because in this situation, that is, if we take the difference, that is dm plus 1 square minus dm square, that will give you dm plus 1 minus dm, another term dm plus 1 plus dm, right? And this quantity, that is 4 lambda r, is constant. That is m plus 1 minus m. So that is 4 lambda r. So this is 4 lambda r, and this is dm plus 1 plus dm, which is equal to twice dm. We can consider that is equal to twice dm. So we have written here 4 lambda r divided by twice dm. Now you see here 4 lambda r, that is twice lambda r, these two will be cancelled out. Twice lambda r divided by dm, that is the beta. Now twice lambda r is a constant quantity. So beta is proportional to 1 by dm. Beta is proportional to 1 by dm. So that means fringe width is decreasing with the increase of order number. With the increase of order number, fringe width is decreasing. That is the evidence that fringe pattern becomes more and more closer if we move away from the central fringe, right? So that's mean fringe width is decreasing more and more with the increase of order number. Now applications of Newton's ring. Okay, there are problem and application that we will discuss later on. I will stop it here, right? I have another assignment, and so I will stop it. In next class, I will discuss the application of this. Point is clear?
Yes, sir.
And
Sir, one thing.
yes,